All right. Good morning. Let's get started. Well, I want you to think about something for a minute. Imagine it was 15 years ago, maybe 20 years ago. Somebody fell into a cave and got stuck over there. And then they sent people to eventually, find out that this person has been surviving for 20 years, rescued this person, and the person happens to be a programmer. And the first question he's curious to know is, what's the most popular language in the world? And they tell him, why, it's JavaScript. Is that even imaginable? So somebody asked me the other day, how do you describe JavaScript? And the best description I can think of is, it's like that bad villain in the movie. They kept trying to kill him, but he keeps coming back to life. Well, that's the way I feel about JavaScript, but I really love this language for a lot of reasons. But I'll be honest about it. It's a language I feared a lot a long time ago. But over the time, I've really gotten into falling in love with this language. In fact, so much so that I actually wrote a book on it called Rediscovering JavaScript. And the reason I really wanted to write this book was that I really felt that there's so much to this language that's much better today than it was decades ago. And I truly believe it's a very respectable language, and that's what I want to share with you today, is my fascination for these features in this language. So in a way, I would say it's no longer the old, scary language that we once really feared or disliked to use. It's a very nice, wonderful, modern language. But definitely, no doubt about it, there are some still very rough edges in the language we got to be very careful about. But there are so many really nice things in this language as well, and that's the beautiful features I want to talk about today. Well, some of the things we want to really keep in mind as we program with JavaScript is there is a lot of syntax in JavaScript that still exists today, and part of the reason is JavaScript doesn't have the luxury of deprecating features in the language like other languages like Java and C# and other languages can do. And part of the reason is twofold. One is there's a lot of JavaScript out there today written long time ago that should still run on modern browsers. And as a result, you can simply discard a world full of code that already exists. You don't have control over it. But moving forward, though, there are a few things we really want to think about. One is, I would argue, quit using var because that's really not a really good syntax. Part of the reason really var is not a good syntax is, Brendan Eich, the gentleman who created JavaScript, said he never expected anyone to take this language serious to begin with. And now, of course, it's all of it isn't really popular, but a lot of things were not done really the way it should be done. For example, if you think about, let's say, max equal to 100, I want to really print the value of max like so. But then if you were to say var max equal to 2, and then you print the value of max, well, how does it really make sense to redefine a variable that already exists in a context? That doesn't make any sense. Nobody in the right mind would want to do. And generally, you would want a compiler or an environment interpreter to kind of tell you, did you really mean that? Well, it doesn't really do that, as you can see. Similarly, if you will, for example, let's say you were to create a block structure in here. And then within the block structure, you say local equal to, let's say, 4. I want to print local. And as you can see, it printed local. But you come out here and say local. Well, that still prints it. Now, why is that? Because JavaScript looks at that curly braces and says, nice curly brace, and throws it away. So it really didn't have a clue what this really means in that context. So a lot of these things were really not done very well, and they really wanted to fix it. But like I said, you don't have the luxury of changing the definition of something that already exists, so they decided to reintroduce introduce a new keyword. So in this case, the keyword really is a keyword called let, for example, and you're simply saying that let max be 100. And now, of course, in this particular case, I want to say max is going to be a value of 100, as you can see. But if I were to say let max equal to, let's say, 2, you'll get an error saying, well, you can't do it because max already exists. But of course, you can reassign to a value if you really wanted to, and that's basically what a let is doing. So moving forward, it's better to use a let rather than a var. But I would go to the next extent to emphasize you really want to prefer a const as much as you can rather than using a let, because a const gives you immutability to that variable, if you will. So as a result, if you were to say max equal to a value of 2, you'll get an error again, as you can see, because you're not allowed to reassign. So my recommendation really is, quit using var moving forward. Use let instead, but even better, const, instead of let where possible. So, but of course, one of the questions you may ask is, but how do you really, make sure you're doing these things properly? This is where tools like ESLint can be really useful, because the tools like ESLint can immediately give you a error or a warning to say, hey, really, did you mean to use a constant in this case, because you don't have to really mutate the variable? Or if you're using a var, it can give you an error and ask you to use a let. So that will be a really useful tool to use. Now, like I mentioned earlier, JavaScript is an extremely powerful language. And it's a language that you really need to take the time to understand and appreciate it. But there are several rough edges around the language that can trip us up. So for example, let's say I want to write a function called max where I take a and b as a value. And in this case, if I say if a is greater than b, I want to, let's say, output the value of, let's say a. And otherwise, in this case, actually, let's return the value of a. So we'll say, in this case, return a. And otherwise, we'll return the value of b, let's say. Well, a fairly simple function, nothing really exciting. But if I were to say max of 1 and 2, the result in this case is 2, which is what we expect. What if I said a max of 4 and 2? The result is 4, obviously. That's great as well. But what if you said max of 21, let's say 81 and 4, and you run the code, it still says 81. And you say, oh my gosh, that's really awesome and smart. How is that we can send 4 different values or 3 different values? Well, actually, in this particular case, it turns out that in JavaScript, every single function is a var arg function. So in other words, it's not how many parameters you define in a function. It's all about how many parameters, arguments you want to send to a function. So you can send as many arguments to a function as you want to. So every single function is automatically a var arg function. Now, obviously, the question is, how do you really access those arguments? For example, in this particular case, if I said 94, clearly the result is wrong because it's not using the last argument, the code is, that is. So how do you really get used to access to that particular code? Well, as it turns out, you can actually throw away those arguments right there, and you can rewrite this function if you wanted to. So in this case, you could say, for example, let's say large is equal to arguments. And in this case, you can say arguments 0, for example. Then you can say for, let's say, let I equal to 0 to maybe I less than arguments.length. And then you could simply specify this right in here. And then you could say, for example, large is equal to, you can say arguments of I is greater than large. Then you could say it's equal to large. Otherwise, you could say it's going to be, in this particular case, arguments of I. And you could write the code like so. But if you were to do so, and let's say return large in the very end of this, there's good news and the bad news with the code like this one. So what is the good news? Obviously, that didn't do the right job here. But large, if the arguments is greater than large, you want to send it to the arguments, obviously, right? And then, of course, otherwise, you want to set it to large itself. So you can see that in this particular case, it's doing the work. But when you look at this code, it worked, and it's extremely powerful. But I would argue there are a few problems with the code like this. The first problem in this code is that it is not obvious. Because when you look at this code, how many arguments can this function take? And the answer is, because it's taking nothing, you can send anything you want to it. Doesn't seem really intuitive, right? So it feels like the opposite day. Because you don't take any arguments, you can send anything to it. It's not very obvious. Second problem is, it's not self-documenting. So you have to really write a document to describe what's going on here, and that's not really a fun experience. I often prefer a code that's self-documenting, so when you look at a code, it's obvious. You don't have to read another pair of documentation addition to the code. The third problem here is that unfortunately, arguments, you could say, while powerful in this case, is not an array. This is one of the disadvantages as well. So if I were to ask arguments is an instance of array, you will notice that in this case, it says false for each one of them. So arguments is not an array, and you can see that I used a square bracket, but it's really something that wanted to be an array but never got a chance to be one. So as a result, unfortunately, you cannot use any really array specific things in the code. So programmers often write a few lines of code to convert arguments to an array. The more code you write, the more bugs you have, the more you have to maintain. Why bother doing it? So the question is, how can this be improved? This is where, nicely, the REST argument really comes in. So what you can do is a beautiful stand-in replacement in the code, if you will. So notice that this code is running right now, but I'm going to simply come in here and say dot, 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 and I'm going to say numbers. You can call it whatever you want to call it within reason, but I just introduce the numbers as a REST argument. What makes it a REST argument is the 3 dots I put in front of it. So now, notice how the code is pretty obvious. You look at the code, it's very clear. You can pass any number of arguments to this particular function. Not only that, if you take the numbers in here, remember it was false a minute ago. Now notice it's true, because the numbers is an array, which means you can use array functions on this as well. And as a result, you can simply take the arguments that you saw here and replace it with numbers like so right there. And you can see that in this particular case, the code simply begins to run just fine with the replacement of arguments with numbers. Well, that's a nice improvement, but because we know that REST is an array, you can go one more step even further and start writing really concise code. I'm a huge fan of writing functional style code. Now, this may come as a shock to you, as I did for me, but JavaScript actually has been supporting the functional style of programming from way back in time. And a lot of us were programming in multiple languages, right? I often say JavaScript is the English of the programming language world, because it's a ubiquitous language, everybody uses it, and everybody uses it with a slight twist and accent like I do. The point is that nobody really speaks it well. So I had a client of mine call me up. They were here in Scandinavia, and they said, hey, we want you to come and teach a course on design, they said. And I was excited. Gosh, I'm going to come and teach a course on design. And about 2 weeks before the course, they called me up and said, oops, we really forgot to tell you that the people in the class will be using 3 different languages. Some of them will be using Java, some of them will be using C#, some will be using PHP. And good luck, how are you going to teach the class for them? So I was thinking, what do I do? If I use Java, 2/3 of the room will be angry at me. If I use C#, the other 2/3 will be angry at me. And then I realized, wait a second, I can use JavaScript, then everybody will be angry with me, right? So essentially the idea is, it is that common language, isn't it? So in this case, of course, you can use the functional programming capability, all right, that's amazing, and you can benefit from that really nicely. So what I decided to do here with this code right now is to go back and say return, let's say numbers.reduce, and I can then say in this particular case, well, I have a large in this case and the number, if you will, and then I can say in this function, well, if large is greater than the number, then simply maybe return the large, otherwise return the number that you have at hand. So you can start writing the code in very concise functional style. Obviously, this code is not complete, and you may have to do a little bit more work with it, but it kind of gets you in the direction you could go. And because numbers is an array, you can use a functional style of code as well, and you can start passing arrow functions and use functions like reduce as well to make things really nicely, as you can see. So that's basically the rest parameter. On the other hand, you can also use what's called a spread parameter and a spread operator. And I really like spread because I would say this is my second favorite feature in the language. Let's take a look at what spread can do for us. So let's go back to this example for a minute and say that I want to take, let's say, a constant, let's say in this case, a number. Numbers is equal to, let's say, 1, 2, and 3, and I want to pass it to the max function. So I could say max like this and say, oh, we could say numbers square bracket 0, and then numbers square bracket 1, and numbers square bracket 2. And if I were to add a comment, I could simply say, I need another job, because that's really boring to be writing that code in such a verbose manner, isn't it? So we want really to make the code concise. You want to feel like you're working with an intelligent language that understands what you're doing. So while you're able to write the code like this, wouldn't it be so much better to simply say, explode or spread the numbers for me and pass them around? So that becomes a lot easier. So that becomes a spread operator. But before we go further with this, just important to keep in mind one small distinction here. So suppose I ask you, what is plus? Well, we all know this. We know that plus is both a unary operator and a binary operator. So in general, when it comes to programming, we are used to duality of operators and functions. They may take two different meanings depending on the context where you use it. Similarly, if you will, if you ask what is ... that is both a rest operator and a spread operator. Here's an easy way to remember it. On the receiving end, it is the rest. Remember the R in the receive and rest. And on the sending side, it is the spread. And again, remember the S in the spending and spread. That's an easy way to remember if it's something you used to receive or something you used to send. So it's both a receive operator and a spread operator at the same time, and you can use it for that reason. This is one of the nice things about spread is spread has nothing to do with rest. They are independent of each other. In the example I just showed you a minute ago, I used spread where the receiving end was a rest, but it doesn't have to be. So for example, if I have a function called greet, which takes names as an argument like so, notice it's not a rest parameter. And in this case, I'm going to say, hello. And I'm going to say names of square bracket 0, and maybe I'll say we'll say names of square bracket 1, like so, and we will pass to it. So now in this particular case, I can say constant names is equal to, let's say we have a Tom and a Jerry, like so in the code. And if I want to call this, I can say greet name square bracket 0 and name square bracket 1, and I can send those two arguments over for the Tom and Jerry as the arguments in this particular case. So we have names and we are sending 0 and 1. So that's one approach we can take to send these values in this collection. You can see that's messing up already right there. So I'm taking the collection of data. I'll say name 1 and name 2. How about that? Which is what I really wanted to get to. So let's say name 1 here, and let's say name 2 in this case. So we have discrete arguments, not a rest in this particular case. Well, that's one way you can do, but it always messes up with Tom and Jerry, as you can see here. But on the other hand, though, if I really want to send this code, why take all this effort? You can once again use the spread argument right there, spread operator, and you can use it. So even though these are discrete parameters on one side, you can use a spread on the other side. A very powerful way to use this in terms of how you can carry over this code. But this also brings up one other interesting capability which I really appreciate. So for example, let's say we have a person equal to, let's say name, and in this case we will say name is Sam, and we will say age is 2, let's say like so. So we have a name and an age, and imagine this is defined elsewhere. So this is defined in some other file. Just imagine that for a minute. Now in our file, we have something like constant, let's say function, which is going to be a copy person, increment age, and I have a person that's coming in as an argument. So what am I going to do here? I'm going to say return, and in this case, I'll say name is person.name, and age is person.age plus 1, let's say, and I want to increment and send it. So imagine this is in a different file altogether. Imagine a fairly number of different files. Maybe you're doing a React application or a Angular and so on, and you got these in different places. So now if I were to go ahead and print out a person, you can see that the name is Sam and age is 2, and you can say constant person2 is equal to copy person. You can make a copy and print out person2 like so, and the age is 3. So everything seems to be going really well at this point. But some of you may observe and notice very quietly, this code violates both the open-closed principle and the dry principle. I know you're thinking, gosh, you didn't even write a lot of code and he's messing up so badly already. Yeah, that's just me. So you can see even that one line of code can violate both dry and open-closed principle. How so? Well, I'm duplicating the effort of copying the fields over. That's a dry violation. But more important, open-closed principle, because open-closed principle says that a particular module of software should be open for extension, but closed for modification. You don't have to change it for it to do something better than what it did before. Well, as it turned out in this particular code, imagine this code exists in the system, and one day you decided to come in here and add maybe one more little detail, maybe a social media ID. The kids are never too early these days to start, and has a little ID for that themselves. Now you can see it's like mom and dad found out that Sam has been tweeting all along and withdraws the permission to tweet at age 3. How sad that is. So this code is not really extensible, as you can see. What can we do to fix it? So the problem in this code is we were taking the pain to really copy over every single a property, and we can actually write less code and get a better, behavior. And that's another place where this can be really powerful. You are simply saying, hey, just copy over the entire object for me, and then only modify that property. The code is a lot more extensible. You no longer are violating the dry and the open-close principle. So much better code, as you can see in this particular case. So that's basically a few things about the spread operator and how we can make use of that very nicely. With that said, let's talk a little bit about a few other capabilities. Along the way, of course, if you have a question or a comment, please don't hesitate. Any time is a good time for questions or comments. Just wave at me, start speaking, I'll listen to you. So don't hesitate at all. So we talked about a few different features. We talked about using constant as much as possible, not using using let if it cannot use a constant, but not using var. Then we talked about using the rest and spread as a better way of writing code. Now, one of the other things about JavaScript is, JavaScript doesn't have function overloading. Now, this is somewhat really funny, but really sad at the same time. I was teaching a course, and I mentioned that JavaScript doesn't have function overloading, and I heard a noise in the room. I looked at the developer, and he said, oh my gosh, now I know why my code has not been working. So sometimes you discover these things really in a bad way, but it doesn't have overloading. So in the case of languages like Java and C#, you can overload functions. So as a result, you can nicely provide 2 different or 3 different variations of a function. But I think JavaScript has something a little bit better, in my opinion, which is to have default parameters. So let's take a look at what default parameters can do for us and understand the behavior of default parameters as well in here. So suppose you have a function called greet, which takes a name, and I'm going to simply say, hello, and then a $name to output the value in this particular case. Now I can go ahead and say greet and pass Jane like so, and you can see it says hello Jane right there when I call that particular method. So that's quite useful to pass the name, and that works. But then we are told we want to really modify the message we pass for the greet to actually greet. So, but we don't want any existing code. So this is existing code, and we don't want to affect any existing code. So what you can do here is you can say Sam, comma, maybe you can pass hi like so, or you can even call Jane again, but you can maybe pass a howdy to Jane like so. So in this particular case, you want to really introduce a new argument so it can be greeting differently. So you can come in here and you can add a message as a second argument, if you will. And then, of course, you can come back here and say, this is going to be a message I want to display. And you can now pass a default argument, and you can say hello, because that's what you wanted the existing code to be using. So you can bubble that up to that. So you can see hello, Jane, but you can see howdy, Jane, and hi, Sam as well. So that becomes really nice. But this only is a beginning of the wonderful feature that you see here. So you can add default arguments very nicely. But then the question is, what if I call the function without any argument? What's going to happen? And the answer is that message is, hello in this particular case. So that makes really good sense. But on the other hand, if I were to pass maybe a little hi in this case, that's also obvious. That's going to be a hi. So that's what you see here. But then the question is, what if you were to pass Jane, but you say undefined like so? Now, if you pass the undefined, what the language has really a meaning to certain things. In JavaScript, undefined simply means non-existent. It doesn't exist. But null actually means that it's a null value. So there's a distinction between the two. Where I really appreciate this is, I was working on an optimization problem, and I would get some data, but I have to refine it further with the data I already have. So I have on one hand a set of data, on another hand I have a set of data, but some data may or may not exist. But if it exists, I want to use the value. If it doesn't exist, I want a default value for it. So because when it doesn't exist, it's undefined, the value automatically comes in as a default. So this can be really powerful. So in this case, message is actually hello, because you did not give a value, it's undefined. However, if you say greet and say Jane and you send null, that's not going to be a fun experience, because message is actually null. And if this Jane was really a friend, she just unfriended you on Facebook. That's not going to be a good way to greet anybody, so don't do that. So essentially, in this case, there's a distinction between undefined and null and how this actually works. But we can take this even further, if you will. And let's say I want to really greet my friend Jerry and pass a message to Jerry. Now, what I can do here, though, is in this case, if you notice, it says, hello, Jerry. But I can modify this like so. And I can say, in this case, a little expression. And I can say hi. And I can even do something silly like name.length. And that's a way I can give high five to my friend Jerry as well. So it's an expression you can write for a default argument. So not only can you give a default value, but it can be an expression which can be doing some calculations as well. It's a very powerful mechanism, as you can see in this particular case. So we saw a few of the capabilities of the default arguments. The next thing I want to talk about here is an enhanced for loop, but that really is going to take us into my most favorite feature, which is destructuring, but I'll talk a little bit more about it in a few minutes. But I just wanted to show you some really cool things you can do with writing for loops, if you will. Now, we all know we can do some things like this. Suppose I had names equal to, let's say, Tom and Jerry as two things in here. And I can say for, and we could do something like this. We could say I equal to 0, I less than names.length, the good old traditional loop that we all have written a million times over. And then we could write something like, for example, the value of I, and maybe a couple of dashes, and then maybe the value of the name at that location. We could write something like this as well. So that's a boring loop, we can write it. But what if I really want to make this a lot more pleasant experience rather than having to write such a verbose code? So this is where the enhanced for loop really comes in really nicely. You can say for, you can say constant name of names. Notice the word const already makes me happier than using a let, and I can simply output the name like so, and we can use that name right there. So that's nice and pleasant. As you can see, fewer moving parts, much simpler to write it, very nice. But then it doesn't quite meet the requirement, isn't it? We really wanted to get the access to the index and the value at that index, and obviously this does not do it. How can we accomplish that? Well, we could probably take a few steps to really get towards that. So for example, you could change this to using an entry rather than using a name, and you can ask it to provide you the values of entries at this particular point, if you will. And then, of course, you can say, I want to print an entry that's given to me. So that's a little step in the right direction. We are still using the off. We are not using the weird, noisy syntax. So we're getting there one step at a time. But then you say, wait a second, I really want the same output as the other code. So what about saying constant, let's say I equal to entry of array, I being 0, and then I can say constant name equal to entry of 1. After all, it's an array. And then I can take this code right here. I can write that code. So we are getting very close to being able to produce the same output as the other one did. Yeah, but we are writing a few more lines of code. Can this not be a bit more concise? This is where an interesting feature called destructuring really comes in. I'm really a big fan of destructuring. I get excited from time to time, as you probably can tell. And one day I was coding away, and suddenly I tweeted saying, today's tweet is sponsored by destructuring. And the reason is I really am a fan of this particular feature, and several languages really support destructuring. So what is destructuring? Well, structuring or construction is creating an object from bits and pieces. Destructuring or deconstruction is the opposite. You take an object and you extract properties from that object. So that's basically what destructuring really is. So what you can do here is you can say constant I comma name is equal to entry, and you can destructure it in a nice little way, as you can see, without having to write them separately. So in this case, the destructuring is extracting based on the position, the first and the second value in the array. But then you can take that further and move the destructuring right there to the very top level. And now you can see the code is a lot more concise. And that's basically what you can do here is to take the destructuring and put it into the enhanced loop. And as a result, you don't have to write a lot of code. You don't have as many moving parts in the code as well. Becomes a lot easier to write it, as you can see. So this is a mixture of both destructuring and the enhanced loop bringing together. Just a couple of mentions before we go further. Template literals are pretty amazing in terms of how you can make the string manipulation really concise. You saw me do this quite often already. So right there is the backtick. Now, this again is a bit of a weirdity, if you will. Languages like Kotlin and Groovy tend to really use a double-quoted string different from a single-quoted string. Well, JavaScript doesn't have that luxury because both single quote and double quote already exist in the language. They don't have the ability to go back and redefine the meaning of existing things. So they decided to introduce a new syntax, which is the backtick for template literals. So if you use a backtick, it is evaluated, whereas a string literal is simply a string literal that it's going to use in this particular case. So that is basically a template string that you see in here. And that really gives us a couple of more things to consider. And an object literal, similarly, is a way for us to really use properties of an object as a local variable context. But I will express that when I talk about destructuring in just a few minutes to look at it. So I'm going to show you two examples of destructuring and an extension of it to see how powerful this idea really is. So first is, let's say, you have a collection of data. Let's say names is equal to, as we saw earlier, you have Tom, let's say, and Jerry, and maybe you have a Spike as well, and maybe you have one more, let's say, Tyke here as well. So you have a bunch of names given to you, and you want the first one. You could say first is equal to names square bracket 0, and you could access that first value. Similarly, you could say in this particular case, maybe a second, and you could say in this case, the second is going to be the second value. You could access this, and you can print the first in here. You can print the second in here as well. But that's pretty boring syntax, if you will. So you could do it, but I wouldn't really recommend it. What you can do instead is you can say first and comma second, and you can simply use the names, and you can do destructuring like so. Now, that's pretty awesome. But what if I want to get the first and second, but I want to get everything else after that? So you can go back here and say all else, and you can print out all else. But how do I really know that all else contains Spike and Tyke and anything after that? You probably guessed it already. You can put a ... on it, and it brings everything into place. Now, while you're at it, you may think, this is all going really well, but in the back of your mind, you're still thinking, but this is still JavaScript. What could possibly go wrong? And this is where I really, really wish they didn't do this. You know, it's almost good, and then you're like, really? So in this case, you could simply say the fourth maybe, but how do I get to the fourth? And I really, if you don't want to see it, it is a good time to close your eyes and plug your ears. I will tell you when you're ready to continue forward. You can put, yes, a comma after that, and this gives you a fourth. The reason I really don't like this is one of your developers gets really anxious and says, that now, and try debugging that code. Now, that's one of the things I really don't like what they did, but unfortunately, that is the case. But without saying that, there are other nice features, as you saw, you can clearly use it. But having said that, let's go look at one more example of this. Let's say we have a function here called, let's say, getName, where that's going to return for us, in this case, maybe a first is going to be a first name. Let's go ahead and say, John. Let's say in this case, a middle, we'll call it as, Quincy. And maybe a last here, which is going to be, Adams right here. We get those values in here. But how do I get those values into variables? So I want to go ahead and print out, let's say, a variable here called the first name. And I want to print out maybe a last name as well. So this is where the syntax is pretty interesting. You can say first colon first name, and let's say a last colon last name, and then you can say middle colon, maybe a middle name is equal to, and you can say get name like so. So the way you want to look at this really is, that you want to think about this as the property name and then a variable name. And a property name and a variable name is the sequence in which you're going to be looking at these variables. Let's see what the error says. It's not happy with the middle in there. So basically in this case we have first is John and middle is, I don't see the error. Anybody sees the error? You restored faith in pair programming for me. Thank you. So as you can see, I can only type code. I cannot read it. So right there, you can see it got the value in there. So that's working. So the way this works is, as you can see, this is going to be using the format of really the property and then colon local variable. That's kind of the syntax it's using. So the first name is the local variable. First is the property. Now, having said that, though, one of the really interesting things is you can mix the idea of destructuring with the object literal together. So looking at this example, what if I don't want to call this as a first name, but I want to call it as a first itself? So you can see in this case, you said first and first, which is kind of a little redundant and noisy. So you can simply remove this first from here. So what this really means in this case is that you have a property name, and the same name is also a local variable if absent. So the property name itself becomes the local variable name. So as a result, as you can see here, that the property name is last, but the local variable is name. Whereas here the property name is first, local variable is first as well. Now, the last example I'll show you for the destructuring here is to take this idea and go further with this nicely. So, for example, let's say you have a function called the print, info, where I say person like so, and within this, I'm going to simply print out, let's say, only the person's first name, like so. I say person.first, and I print the first name alone right there. So if I were to only print the first name of the person, I'm going to say print info and get name and call it. But that's verbose code, but also it doesn't clearly say what we really expected. We only want it first. In fact, I would argue you're misguiding because you don't care about a person. You care about a property called first name. That's all you really care about. So what you can do to refactor this is to say constant, first is equal to person.first, where I'm going with this. So you can use the first here like so. But then you can take that refactoring one more step further and say, well, a curly first, and I can simply say is equal to person. You can apply the destructuring, then take the destructuring all the way through and simply replace that as a first. And as a result, you can destructure while you're receiving the argument to the function at the same time. So again, you can mix default arguments with this as well if you wanted to. So for example, if you wanted to, you can say comma age, is equal to, let's say 40, and you can print the age as well. And if the age doesn't exist, the default value is given. If the age were to be present, you would notice that the age was different. So you can use default arguments with the destructuring as well on function arguments. Very powerful. So in about the next 7 minutes left with us. Oh, yes, please, fire away. Thank you.
Yes, I've got a further question on destructuring.
Yep.
Is it possible to do case-based destruction in the same style as your Erlang or standard ML?
No, not to my knowledge. You can't. Maybe in the future. Maybe you can make that happen. Yeah, well, the time is infinity. There's no rush for it, right? So yeah, not to my knowledge, I don't think you can do that. So with that said, let's talk a little bit about one other thing you got to be careful about. Well, I'm a huge fan of arrow functions, But at the same time, we got to be very careful about a semantical difference in the way JavaScript deals with arrow functions. So for example, let's say you have a function called greet, let's say, and the greet function takes a name, and I want to simply output right here, let's say, hello, and a dollar name like so. Well, that's a regular function you could call greet. You can say Sam here, and you can see that in this case, it's going to display greet. But what if I can rewrite this as an arrow function rather than as a regular function? So you can say constant greet equal to name arrow, and then you can simply put the console log like so, and becomes an arrow function. So when you look at this code, you say, hey, that's nice. It's a fewer syntax, less noisy, so we should be really happy with it as well. So absolutely, I like it, but unfortunately, there is one problem. I'll mention this here. We won't have time to go into the details right now, but I'll mention a few things. I'm going to say there are, if a function does not have a variable defined, what happens. So if a variable is not defined, then the compiler or the interpreter or the runtime needs to find that variable somewhere. So there are a couple of different ways in which you can do this. And I'm going to say kind languages use what is called lexical scoping. So what is lexical scoping? Lexical scoping is where the variable is known in the defining scope. To say in simple words, you can eyeball the code and say, that variable there is not defined, but it's the one over there. You can look at it, you can see it. As a programmer, you understand the code. That's why I say these are kind languages. Now, kind languages use lexical scoping. I'll say unkind languages use what I would like to call as dynamic scoping. Dynamic scoping is very powerful, but it's not that easy on us because the variable is given to us based on who the caller is. So the same function with that undefined variable, the value depends on caller 1 versus caller 2 versus caller 3. You don't know which one by looking at the code. It is dynamic based on when it's called. And I like to call them as unkind languages. There's not that many of those in the world. But I'm going to say evil languages, what do? Use both. I once tweeted this, and I said, when I die, on my tomb, I want somebody to write these words. This man never got this, because this is really evil. Well, it turns out, unfortunately, that in ordinary functions, this and arguments are dynamically scoped, and all else are, lexically scoped. So this is of course, I forgot to ask you the question, do you know of such an evil language, right? So essentially, in the case of JavaScript, as you can imagine, the ordinary functions, this and arguments are dynamically scoped, and all else are lexically scoped. On the other hand, unfortunately, in arrow functions, you need to keep in mind, everything, is lexically scoped, including this and arguments. So you cannot just take a function and convert it to arrow function and walk away, because the building will burn down to ground if you do that. You need to still understand that they are semantically different from each other. This is one of the reasons why you got to be very careful using arrow functions, because within arrow functions, if you use this, the behavior is very different from how this works in normal functions, and you got to be very comfortable knowing that difference. So even though it's syntactically much more concise and better, it is something you have to be very careful knowing the syntactical differences between them. Once we understand the difference between them, I would say that arrow functions are pleasant to use as long as you can verify what they do is actually what you want them to do, and that becomes a lot easier to work with. So just be mindful of that. So to summarize what we talked about, The language has some really amazing capabilities. It's a language that's come really, really far into the development. A lot of things that used to be really painful have been, reworked in different ways. And like I said, JavaScript doesn't have the luxury of deprecating features. So the old stuff, the scary stuff is still there, but newer stuff have evolved to provide a much better experience. And what I covered here is maybe about 40% of what I cover in the book. But if you're really interested in it, I encourage you to take a look at the book Rediscovering JavaScript as well. I really hope this was useful. Thank you so much for joining.